Spatial data could be captured directly from the environment, and that kind of data is known as primary data, obtained through ground-based field surveys, or by using remote sensors in satellites, airplanes, or drones. Any spatial data which is not captured directly from the environment is known as secondary data. This includes data derived from scanned paper maps, data digitized from a satellite image, processed data purchased from data capture firms or international agencies. There are two models for representing geographic data: the vector model and the raster model. A vector model corresponds to a geolocated shape, which can be a point, a line, or a polygon with an array of associated attributes. Raster data in GIS are matrices of discrete cells that represent features on, above, or below the Earth's surface. Each cell in the raster grid has the same size, and cells are usually rectangular. In QGIS they will always be rectangular. Typical raster datasets include remote sensing data, such as aerial photography, and satellite imagery, modeled data, such as an elevation matrix or digital elevation models, DEMs, and scanned paper maps. Some of the most common raster file formats are GeoTIFF and ASCII grid, and for vector files, those are shapefile, GeoPackage, and CSV. The concept of topology defines how places and locations relate to one another, how nodes, edges, and faces can relate to one another through the concepts of containment, connectedness, and adjacency. If you start drawing a line or polygon and notice a green cross mark on it, that means that there is some self-intersection in it. If you finish drawing at that moment when green cross marks are present, you will get an object with bad topology or geometry. But if you continue drawing and there were no green cross marks anymore, a topology of an object is all right. If the misplaced vertex resulted in self-intersection, and a green cross mark is present, you can press a backspace key or delete key and remove the last placed vertices, including a misplaced one, and then continue with adding the new ones. If an object has already been drawn and it consists of a topological error, you can click on a vertex tool and fix the topology manually by moving a vertex. Topology refers to the spatial relationships between geographical elements in a dataset that do not change under a continuous transformation. The change between projections would not alter topology. Topology is fundamentally used to ensure the data quality of spatial relationships. Layers with topology errors may lead to incorrect results. Doubled vertices at each node of a polygon are also meant to be a topology error, as well as self-intersections. Measuring area and doing other spatial analyses won't be possible if some of the objects have this kind of error. Those GIS functions do not tolerate topological errors. If you want to find an object with a bad topology within a layer, you can use the Topology Checker plugin. You can find it in the Vector drop-down menu. If it isn't there, go to Plugins, Manage and install plugins and search for Topology. To identify invalid geometries, click on Configure. and select a layer you want to check out, as well as must not have invalid geometries, and add it as a rule. After that, click on Validate All. You will get a list of such objects and all of them will be highlighted in red. There is also a built-in grass tool that can fix various topology errors in vector layers. In Processing Toolbox, search for Clean and double-click on Clean. After selecting the layer, press Run, and as a result, you will get a new layer that is called Cleaned. Some tips to keep the geometry of your objects clean. Avoid self-intersections. A classic example is a bow tie. Avoid adding duplicate vertices. And avoid making overlapping polygons within the same layer. Attribute, or thematic data, further describes objects in the layer. Attribute data is quite often arranged in tabular form, maintained in a geodatabase. To access the attribute table, right-click the layer and select Open Attribute Table. Each row in the table represents an object, and each column contains a particular piece of information about a particular object. As in the main QGIS window, here you'll see a yellow pencil icon for turning on the editing mode. Once the layer is in editing mode, you'll be able to make changes in the attributes table content. Double-click on a cell in which you would like to make a change and type an attribute value or make a change. Depending on the data type that is used to represent the specific attribute, you won't be able to type text values in columns dedicated to numeric data. A data type is defined at the very beginning of forming a new attribute column. For adding a new column, click on the icon New Field. You will need to enter a field name, a field type, whether it is an integer or a whole number, real or a decimal number, text or date. There are options to delete existing columns and sort their order. If your attribute table does not look like a table anymore and instead of a table you have an objects list on the left side, and only shown attributes of an object on the right side, you can switch from that so-called form view to the table view by clicking the icon in a bottom right corner. To manually select an object within the attribute table, you'll need to click on the row number on the left side of the row. Multiple objects can be marked by holding the Control key. A continuous selection can be made by holding the Shift key and clicking on the first and the last row numbers on the left side of the rows. That will result in selecting those two objects and all objects between them. By selecting features using an expression, you can filter out features that you specifically want. For example, in a shapefile of World Heritage sites from the UNESCO site, there are attribute data about their names, coordinates, the country where the site is located, the year when the site entered the UNESCO list, and so on. Now let's see which heritage sites are situated in the Northern Hemisphere. Take a look at the attribute table and see what column could give us info if the site is situated in the Northern Hemisphere. The Northern Hemisphere is the half of Earth that is north of the equator. Everything north of the equator has positive latitude values, so we'll need the latitude column. Click on Select Features using an expression, expand the Fields and Values section, and double-click on the latitude label to add it to the expression section. Type the greater than 0 and press on Select Features. In the title bar of the attribute table, you can see the number of selected objects. There are selected objects all over the table. For a better overview of selected objects, click on an icon with a blue top pointing arrow so all the selected objects will always be shown in the top rows of the table. Just a quick glance at the map will reveal the results of your selection.